Hello students, good evening. So today I will be delivering the second part of remainders. Yesterday we covered, in the part 1 we covered level 1, level 2, level 3, all these total 16 questions. And today we have to cover textbook question and JEE mains questions. 6 questions, textbook question basically from the Cengage book. I've referred to that. And JEE Mains 2021, this 6 questions. So in total, there were 6 questions in the 16 sets of JEE Mains 2021, 6 questions on remainders. So we will be solving them using the new skill we have learned of using the REM function. Okay, students. So before we start with the questions directly, there were 4 to 5 properties of REM function that we discussed yesterday. We will revise them first. It is important to revise those properties. Quick revision of the properties, just for the properties. So for the REM function, first thing is, so I will just give the examples directly. So if you are saying that REM 31 raised to power 17, remainder of 31 raised to power 17 with 5. Okay, students. So what we do is general method that we replace this 31 by its remainder with 5. So what we get is REM remainder of 31 with 5. This is actually 1 and raised to power 17. So this simplifies our task. 1 second, students. So this simplifies our task, replacing 31 with its remainder with 5, that is 1. And finally, we get the answer of 1. So this is the basic principle, that you have to replace the particular number with its remainder with the divisor. Second property is also fairly intuitive. The property is that the remainder is distributive. So simply put, if you say remainder of 7 plus 4 with 5, so you can directly say it is remainder of 7 by 5 plus remainder of 4 by 5. So remainder, this function is distributive. Right now, I'm just showing an example. So you can just distribute it. So what will be the answer here? It will become 2 plus 4. So 2 plus 4 gives us what? 6. But we will not write 6 since we are calculating the remainder with 5. So here it came out to be 2. Here it came out to be 4. But we will not write 6 because remainder with 5 should be between 0 and 5. So I will just subtract by 5 over here. I'm subtracting by 5. And ultimately I'm getting answer as 1. So if you would have just added them, remainder of 11 with 5, 7 plus 4 is 11, remainder of 11 with 5 is also 1. And here also, since remainder is distributive, we are getting it as 1. Okay, students. Same way, it is distributive while we are doing multiplication. So if you say REM of 4 into 9 with, say, so make it 14, 14 into 9 with 8. Okay. So one thing is that you do 9 into 14 and then take the remainder with 8. Or you can just replace these two particular numbers with their remainders with 8. So this becomes, instead of 14, we will just write 6. Instead of 9, I will write 1. So ultimately the answer, you can see, it is REM, remainder of 6 with 8, which is nothing but 3. Sorry, which is nothing but 6. So here also, if you would have done 9 into 14, then 126, remainder of 126 with 8. So you will say 15 into 8. 8 15 times is 120. So with 126, remainder would have been 6. So same thing is over here. So it while they are in multiplication, then also we can just replace the particular numbers by the remainder with the divisor. Fourth property was related to negative remainders. This is actually a tool for us to simplify calculations. So negative remainders. So what was it? So I would say remainder of, say, 14 raised to power 13 with 5. We have to calculate. So I told students, I explained it to students. So instead of writing remainder of 14 with 5 as 4, I would write it as minus 1. So I will take the negative remainder. So this will become remainder of minus 1 to the power 13 with 5. So I replaced 14 with -1. Very nice. And then this becomes remainder of -1 raised to power odd is -1, remainder of -1 with 5. So this value is nothing but -1 only. So remainder is -1. But since we have to make the value remainder with 5 is always between 0 and 5. So I will add 5 over here. So -1 plus 5. So it will become 4. This is equal to 4. So answer to this question is 4. What I did, I used negative remainders, concept I explained yesterday. 14 remainder with 5 is 4, but I wrote it as -1. -1 raised to power odd is -1. So this is -1 over here. And but then remainder is coming out to be -1. 1 second, students. So the remainder is coming out to be -1. And I cannot write it as -1. I have to add 5 because remainder with 5 should be between 0 and 5. So -1 plus 5, I added 5 to get the answer 4. So these were the 4 broad properties, which is the basic for REM function, remainder function. Another 5th critical property was this. So this was, you can say this is a special property. Special. Simple. When I'm using the REM function and I have some dividend, say 32, and the divisor is say 24. So either we can write simply answer is 8. Okay, the remainder of 32 with 24 is 8. But if we are doing some cancellation, if we are factoring out some number from the dividend and divisor both. So say we are factoring out, here we can factor out 4. So this becomes, or we can factor out 8. So this becomes what? 4. And this becomes, factoring out 8, this becomes 4. This becomes 6. So what we have done, we have factored out 8. So within REM function, yes, it is not like it's not allowed. It is allowed to cut the dividend and divisor by certain factor, but then you have to place this factor which has been cut out before the remainder. So this 8 which has been cancelled from both the dividend and divisor, it will go to the left of the function. So it will become 8 times REM of 4 by 6. So this is nothing but 8 into 4, 8 into 4. So I don't think there was any use of doing this, because ultimately we are getting the value of 32 only. And again, we have to then subtract this with 24 to get the answer 8. This happened because this was a short value. But the crux is this. So crux is this. So you can just omit this part since I have to explain the property only. So crux is this: whenever you are factoring out any number from the dividend and divisor both, say 8 in this case, then that 8 will come to the left of the function, and then you will get the correct answer. Okay, students, so this property we will be using eventually afterwards. Let me think of another example where this thing is used. So tomorrow yesterday I had an example. So remainder of 21 with 18, that will give 7 by 6. Okay, so let me give you a better example here where this property is used. So another example will be remainder of 21 with 18. So remainder of 21 with 18, you know the answer is 3. But if we do factor out, so if we factor out say 3, so here we are left with 6, we are left with 7. So we have factored out 3 over here. So 3, we will remember this 3 and we will put it to the left of the function. So this becomes 3 times REM, 7 with 6. 7 divided by 6, remainder of 7 with 6. So this value we know, this is 1, this is 1. So this is nothing but 3 into 1, which is 3. So what we understood, remainder of 21 by 18, we already knew it is 3. The answer is correct. But if we are doing this method that we are factoring out the dividend and divisor by some, say we factored out 3 over here. So then 3 came to the left of the function, and then we did the usual remainder of 7 with 6 is 1, and then we got the right answer. So remember this step. This is a special property. We will be using this in certain JEE main questions. Okay, students. So now it is time to do textbook questions, and let's see how we are able to do them. Give me a second, 1 second. Okay, so keeping the first question in front of you, the remainder when this expression is divided by 10. So see students, when the question, in the question, if it is asking remainder when it is divided by 10. So divided by 10, what does this mean? Divided by 10 simply means that you have to tell the unit digit of the given number. So here the number is this. You have to just tell me the unit digit and you will get the remainder with 10. Similarly, if it is asked what is the remainder when divided by 100, what is the remainder when divided by 100, then you will have to tell last two digits, basically tens and unit digits both, and so on. If it is asked divide by 1000, then last three digits. So I've already made a video, just for your knowledge, for calculating the last two digits of any possible number. You can refer to this in my channel only. There is a video which contains the information regarding calculation of last two digits of any number. Now coming back to this question. So this is a very simple task. Calculating unit digit is very simple. I've covered this also in the video. So see, what is our number? 27 raised to power 10 plus 7 raised to power 51. So what is the method for calculating unit digit? As I have explained in the video also. So for the base, so these are two separate numbers. Okay. For the base, you will delete all the digits except the last digit. So you will cut out all the digits except the last digits. So this we are remaining with 7 raised to power 10 plus 7 raised to power 51. Similarly, with the power, we just have to take last two digits and rest digits can be cancelled. So already we have just two digits. 7 raised to power 10, 7 raised to power 15. So the method for calculating unit digit if the last digit is 7 is that the cyclicity of 7 is 4. Okay, so what you simply do, you replace these particular powers 10 and 51 by their remainders with 4. So you replace these particular powers by their remainders with 4. So this becomes 7 raised to power, remainder of 10 with 4 is 2, plus 7 raised to power, remainder of 51 with 4, this is 3. Okay, now for 7 square we know the last digit is 9 because it is 49. And for 7 cube, we know the last digit is, it is 343. So the last digit is 3. So 9 plus 3, this becomes 12. But since we are only concerned with the last digit, so last digit will be 2. So last digit, unit digit of this number is 2. Hence our answer is also 2 because remainder with 10 will also be 2. So answer is 2. So if this step is not clear, why I have replaced, so what I did over here, I took remainder of 10 with 4 and I took remainder of 51 with 4 and I simply, so this was 2 and this was 3. So I simply replaced the 10, the power of 10 with 2 and power of 51 by 3. So if this happened because the cyclicity of the powers of 7 for the unit digit is 4. So that is why I take remainder 4. If the step is not clear, just go back to my video in which I have the heading is last two digits of any number. So in that I have explained it thoroughly that how we do this process. So this is in the part where this is in the initial part where we are calculating the unit digit. So I hope students this was really simple. Let's move forward now. So answer is 2. You can refer to my earlier video on last two digits. That concept will be clear. Okay. Now coming to the real questions. Remainder of 5 raised to power 90. So these are textbook questions from Cengage DPP and we are now observing that after knowing this concept of remainders, how we can easily solve this question. So you will see for yourself. Remainder of 5 raised to power 99. 5 raised to power 99 with 8. So as I told you yesterday, we have to check those powers of 5 which are closest to 8. So 5 raised to power 1, 5 square. Okay, so 5 raised to power 1, this is 5. 5 square is 25. Now it is very close to a multiple of 8, which is 24. So 5 square is the power we are looking for, and we will divide this, we will break this power 99 in parts of 2. So how we will do it? So basically you can write it over here 99. This is what? This is 44 into, this is 49 into 2, which is 98 plus 1. So this is how I will break the power. We have learned this yesterday, very basic stuff. So this is REM 5 raised to power 2 raised to power 49 into 5 raised to power 1 divided by 8. Simple. Now what is this thing? This thing is 25. So let me write it down. Better to write it down, write all the steps initially so that you learn it better. 25 raised to power 49 into 5 divided by 8. Now what we will do? We will just replace this number 25 with its remainder with 8. So this is equal to REM. So remainder of 25 with 8 is 1. So 1 raised to power 49, it is 1 only. 1 into 5 divided by 8. So ultimately what we are getting is REM 5 by 8, which is equal to 5. So simply answer is 5. So students, this is the basic thing. If you are seeing this video and having some problems, then go with it, the part 1 of remainders. Okay, so then you will be able to do this stuff easily. So here it was 25, I replaced it with 1 raised to power 49, and 1 raised to power 49 is 1, so that is why only 1 is there. So answer is 5. Pretty easy question, textbook questions. So answer is 5. No need to use binomial, as you can see. Next, so remainder of 5 raised to power 99 with 13. So last it is clear, answer was 5, and here also answer was 5. Remainder of 5 raised to power 99 with 13. See which powers of 5 are closest to the multiple of 13, to some multiple of 13. So 5 raised to power 1, 5 square, 25 will give us. So say 5 raised to power 1, this is 5, 5 square is 25. Now 25 is very near to 26, which is 13 into 2. So now we know we have to break 99. We have to break 99 in powers of 2. So what I will do again, I will write 99 is equal to 49 into 2, which is 98 plus 1. So this becomes REM remainder. So this becomes 5 square raised to power 49 into 5 raised to power 1 divided by 13. What happened? One thing. This is hanging. I'm just refreshing. Okay, now yes, great. So this is 5 square raised to power 49 into 5 raised to power 1, just broke 99 into parts of 2. Then this becomes REM remainder of 5 square is 25 raised to power 49 into 5 raised to power 1 with 13. Now we know what we have to do. 25 has to be replaced with its remainder with 13. So I will write REM, replace 25 with, instead of saying remainder with 13 is 12, use the negative remainder, say remainder with 13 is minus 1, because it is minus 1 away from 26. So this is minus 1 raised to power 49 into 5 by 13. Okay, so minus 1 raised to power odd. Minus 1 raised to power odd is minus 1 itself. So this quantity will become minus 1 into 5, minus 5. So remainder of minus 5 with 13. So this is nothing, but we can say remainder is minus 5. So last step, next step, since we know that remainder with 13 is between 0 and 13, so we will be adding 13 to this. So 13 minus 5 will give us the answer, which is equal to 8. So answer is 8. Simple procedure. Ample questions discussed like this yesterday, part 1. So answer is 8. Very simple. Let's go ahead. So answer is 8. Great. Let's proceed. Answer it. Okay, so value of this thing, 3 raised to power 2003 divided by 28, fractional part of this. So see, when you have fractional part, how you will proceed? First, I will write this thing. So 3 raised to power 2003, this is the dividend. Okay, so I'm writing in this way, dividend is equal to divisor into quotient plus remainder. So it is better we write it this way. So dividend is 3 raised to power 2003. What is the divisor? Divisor is 28. We will get some quotient. Say quotient is Q. And then the remainder is R. Okay. Now what I will say, divide this equation by 28. Divide this equation by 28. So this becomes 3 raised to power 2003 divided by 28. This is equal to Q. 28 will get cancelled plus R by 28. Okay. So we have this thing 3 raised to power 2003 divided by 28. It is equal to Q plus R by 28. Now if you observe this part Q, it is an integer. This is an integer. Quotient is some integer. And this part R by 28. Now since we know, in the side I will write, since we know remainder with 28 is something which is greater than equal to 0 and less than 28. Okay, basically less than equal to 27. So since remainder is something which is between 0 and 28, R by 28 will be a quantity which will be between 0 and 1. So if some quantity, it is between 0 and 1 and this is the integer. So can I say that simply Q is the integral part of this thing? Integral part of this value 3 raised to power 2003 divided by 28, and R by 28 is simply the fractional part of this quantity, because fractional part is between 0 and 1. So fractional part of 3 raised to power 2003 by 28. So if this much is clear, that Q is the integral part of this value and R by 28 is the fractional part. So it is clear to us that if we are asked 3 raised to power 2003 divided by 28 fractional part of this, so basically fractional part of this number is this thing, R by 28. So all we have to do is find the remainder R. We have to find the remainder R and divide it by 28. That will be our answer. So if there is a fractional part of like this, so you just break it, use dividend is equal to divisor into quotient plus remainder, so that you are sure that the fractional part value is coming out to be R by 28. So just calculate the remainder and divide by 28. Okay. So I think this explanation is clear to you. Now I will proceed to solve this question. Just find the remainder and then we will divide it by 28. So remainder of 3 raised to power 2003 with 28. 3 raised to power 2003 with 28. So again, I know here the power of 3 that will help us is 27 because it is minus 1 away from 28. So I need to break this 2003. I need to break this 2003 into parts of 3. So see 2003, this is equal to, if we divide it by 3, this is 3 into, so we will get 6, 206, 237. Okay, 237, and then a remainder of 2. So this is how we will break 2003. 3 into 667 plus 2, 3k plus 2 form basically. So this becomes remainder of 3 to the power 2003. So 2003 is what? 3 raised to power 3 raised to power 667 into 3 square divided by 28. So what is this value? This value is remainder of 3 cube is 27. 27 raised to power 667 into 9 divided by 28. This value is nothing but, so we will replace 27 with its remainder with 28. REM 27 remainder with 28, it is minus 1. So minus 1 raised to power 667 minus 1 raised to power odd will be minus 1 only. So minus 1 into 9 by 28. So this value becomes remainder of minus 9 with 28. So minus 9 with 28, I will simply write it as minus 9 plus 28 because I have to make it positive between 0 and 28. Plus 28. So 28 minus 9. 28 minus 9 is 19. So remainder is coming out to be 19. This thing is clear to you, I know. So answer is 19 by 28. I will just explain again why we will keep the answer as R by 28 when fractional part is involved, so that it becomes very clear to you. So remainder I calculated as 19, and I know the answer of fractional part of this value will be R by 28. So answer is 19 by 28. So 19 by 28 is correct. 19 by 28. Now I'm just explaining this thing again, that why R by 28 is coming, remainder by 28 is coming when we are taking fractional part of this thing. So just see. So dividend is equal to divisor into quotient plus remainder for now. Okay. So 19 by 28 was the answer. Let us proceed now. I hope for everyone it was clear. Okay. So find the remainder when this thing is divided by 7. So it should be a simple task. Let us see. So the question is asking remainder. We are still covering textbook questions. Okay. There are 6 of them in total. I think we are done with 4 of them. This is the 5th one. Remainder of 1690 raised to power 2608. Since this remainder is distributive, I'm already breaking it. So I broke the number with 7. Okay. So 1690 raised to power 2608 raised to power 1690 divided by 7. What can we do over here? Let me see. I think it is best that we do our standard approach, which we have learned in remainders. We will replace 1690 and 2608 with their corresponding remainders with 7. So this is REM. Remainder of 1690 with 7. What is this? So this is 14, 29, 28, 103. This is 3. So I'm just putting 3 raised to power 2608 by 7. Okay. Then plus remainder of 2608 with 7. How much is this? So this is 2150, 4918, 4. So this is 4 raised to power 1690. Okay, we are going fine. Now 3 raised to power 2608 and 4 raised to power 1690. So in order to make this more simple, we know if there is 7 and we have to check the closest power of 3. So 3 square 9, 3 cube 27. So 27 is minus 1 away from multiple of 7, which is 28. So powers of 3 will be helpful to us. Okay, so in order to make it simpler, what I'll do, you see remainder of 2608 with 7, this is 4, but let me write it as minus 3. Okay, by the concept of negative remainder. Why I am writing this as minus 3? Because this will help me, because I already know the powers of 3 which are closest to 7. So it is minus 3 raised to power 1690. So this thing will become plus remainder of, so minus 1 raised to power even, this is 1. So this is 3 raised to power 1690 divided by 7. And here we already have remainder of 3 raised to power 2608 divided by 7. Okay, so let me write it. Great. Now I just have to separate 2608 and 1690 into parts of 3, because I will be using the fact that remainder of 27, 3 cube with 7. This is, so 27 by 7, it is minus 1 away from 28. So this is minus 1. I will be using this fact. So let us do it in the next slide. This much work is required for this question because numbers are such. So first we have 2608. So 2608, this is equal to 3 into how much? So this is 8, then 206, then 28. 28 is 9 plus 1. So this is how we will break 2608. Then we have 1690. 1690. So this is 3 into 15. So this is 5. 19. 19 is 6. 10. 10 is 3 plus 1. Great. So our job is almost done now. So I will just write the expression again. So this was remainder of this expression. So 3 raised to power 2608 divided by 7 plus remainder of 3 raised to power 1690 divided by 7. Okay. So now I will write this as remainder of 3 raised to power 3 raised to power 869 into 3 to the power 1 divided by 7 plus remainder of 3 to the power 563, 3 to the power 3 raised to power 563 into 3 to the power 1 by 7. So by now, in all the questions, we are just using that 4 to 5 properties of remainder. Sometimes the questions are a little lengthy because of the numbers involved. That is it. We know we will be able to solve it. So now this becomes remainder of, so 3 cube is 27. Its remainder with 7 is minus 1. So minus 1 raised to power 869, minus 1 raised to power something odd is minus 1 only. So what will be remaining over here? Minus 1 into 3, so minus 3 by 7. I am skipping the steps because I think now you understand. So remainder of 3 cube, so 3 cube is 27. Remainder of 27 with 7 is minus 1. So minus 1 raised to power odd is minus 1. Minus 1 into 3 is minus 3. By now we have become experts. Remainder of, in at least the calculation, remainder of again 3 cube. 3 cube 27. 27 is minus 1. Remainder of 27 is 7 is minus 1. Minus 1 raised to power 563. Minus 1 raised to power odd is minus 1. So this is again minus 3 by 7. Minus 1 into 3 is minus 3 by 7. So what is the expression coming out? This is minus 3 plus minus 3. So it will become minus 6, but we have to keep the remainder value, actual value between 0 and 7. So we will add 7. So answer becomes 7 minus 6 equal to 1. So answer is 1. So great, we found the answer. The answer is 1. Answer is 1, students. Okay. So here also you see, first let me explain my method again. So simple thing, we know the approach. So first I use the property that the remainder is distributive. This is the answer. Let me write it above so that there is no confusion. 1. Okay, so first I use the property that remainder function is distributive. So I broke it into 2 parts, broke the number into 2 parts. Then I replaced 1690 with its remainder with 7 and 2608 with its remainder with 7. Instead of 4, I took it minus 3 because I knew that 3 cube by 7, the remainder is minus 1. So that is why I kept it as minus 3 instead of 4. Then this became remainder of 3 raised to power 2608 plus remainder of 3 raised to power 1690 by 7. So I knew I had to use this property, remainder of 3 cube with 7 is minus 1. Okay. So then I proceeded. This part was a little something that it is compulsory to do, that we have to break 2608 and 1690 into parts of 3. So I did it and I wrote it like this. So 3 raised to power, this was already copy pasted from previous slide. and this is 3 cube raised to power 869 into 3 raised to power 1. And similarly over here, then I did the standard method, use negative remainder, that got the final answer as 1. So this step, although it is little lengthy, it is compulsory, and we got the answer as 1. If you look at the textbook solution using whatever they are doing, binomial or whatever, so they have also done this thing over here. Okay, so you can see I've highlighted it, that they have also separated those two huge numbers into parts of 3. So this was mandatory step. This instead of this solution, we will be using the solution I have told you using remainder. So by now we are experts in this. Happily going forward. So answer was 1. So this is why my solution is helpful. Find the remainder. Last question from textbook, then we will be doing JEE main question. Find the remainder when x is equal to 5 raised to power 5 raised to power 5. 24 times 5 is divided by 24. Okay. So here it is, remainder of 5 to the power 5 to the power 5 to the power 5 to the power, and so on. Okay. With 24. Okay. So I will just see that this power tower is there. Okay. This is some power. Now, ultimately, I want to find out remainder of some power of 5 with 24. So I will see the power of 5 which are closest to 24, and simply I know remainder of 5 square is 25, which is plus 1, which gives the remainder of plus 1 with 24. So I'm writing it over here. Remainder of 5 square, 25 with 24. This is 1. So I will be using this fact. Okay. So in order to use this thing, that remainder of 25 and 24 is 1, I need to break this power into parts of 2. So what is this power? Let me have a look at this power first. It is a simple question, very simple, two-step question. Power is, so it is 5 raised to power 5 raised to power 5, 23 times, because already we have taken 5 as the base. So 23 times. So I need to divide it into powers, into parts of 2, because 5 square is giving remainder 1 with 24. So I just need to check that whether this thing is even or odd. Okay, so whether it is 2k form or 2k plus 1 form. So it is visible to us that 5 is an odd number. 5 is an odd number, and 5 to the power anything will be odd only. So this power tower, this value is definitely odd. Definitely odd. 5 is to power 5 is to power. This is definitely odd. Basically, this is 2k plus 1 form. This is 2k plus 1 form. So I will just simply replace this power tower with 2k plus 1. So 5 raised to power 2k plus 1. Now I will use the fact that with 25, 24 is giving remainder as 1. So see, now how simple the question will become. This becomes equal to Rem 5 square to the power k. So we did not know what k is. And then into 5 to the power 1 divided by 24. So next step is replace this 25 with its remainder of 24, which is equal to 1. So I will replace this 5 square with 1. So 1 raised to power k, I know it is 1. So what I'm left with is remainder of 1 into 5. So basically remainder of 5 with 24. Since the shaded region, this is 1 raised to power k. 1 raised to power k is 1. 1 into 5 is 5. So for remainder of 5 with 24, this is answer is what? 5. So very simple question. Answer is 5. So it is nothing in front of the level 3 questions that we did yesterday, the power tower level 3 questions. There's still a lot of pattern thinking was required. A lot of thinking was required. This is fairly simple. What I did, see, I used the fact that remainder of 25 with 24 is 1. So I just had to see whether this power tower is odd or even. So I know this is odd. It is visible to me. So 5 raised to power 2k plus 1. 5 raised to power odd divided by 24. So 5 raised to power 2k plus 1, it becomes 5 square into k into 5 raised to power 1. 25 raised to power k into 5 raised to power 1. 25 with 24 gives the remainder of 1. So this shaded part, this becomes 1. Remainder of 5 with 24 is 5. So answer is 5. So very easy. Very easy. In front of the question that we have done yesterday. Remainder is 5. So great, students. So by now, I have completed with you the textbook questions. Okay, so from Cengage DPP, whichever questions on remainders from the Cengage textbook, whichever questions on remainders I could find, I have completed them. And 6 questions were there. I have completed them. Now we will start with JEE Mains 2021 PYQs. 6 questions we will be doing. So let us proceed. JEE Mains 2021 PYQs. Just a second, students. Okay, students. So we have now 6 questions of JEE Mains 2021 PYQs, and we will be learning new concepts in these questions, and we will see how our concepts of remainders, how the REM function will help us solve these questions just by thinking logically. Okay, so a lot of learning in these 6 questions. Let us go. So remainder of this when divided by 18. Okay, usual steps. Apply the REM function and break it into parts. So REM 3 into 7 raised to power 22 divided by 18, and then I will show you the solution, actual solution with binomial, which looks so complicated in front of the simple solution with REM, in which we will just use couple of properties which I've already learned of REM function, remainder function. So I am breaking it. All 2021 PYQs. Fair enough, since remainder function is distributed, I have just broken it into parts. Okay. Now see, the temptation over here is that I cancel out 3 and 18. So I am dividing both the divisor and dividend by 3. Okay, we can do that. We can do that. So then this 3, since I have taken out 3 from both dividend and divisor, I will keep this 3 on the left of REM function. Great. Second part. So here temptation is, we want to factor out 2. So 2, this becomes 1, this becomes 9. So I factored out 2 from both numerator and denominator. Factor out 2 from both numerator and denominator. So I will take out 2 and put it on the left of the REM function. And this thing. So I think it is visible that this thing 44 with 18, this is 36. This is value is 8. This value is 8. Nothing big in this. This value is 8. Because 18 into 2 is 36. So 36 plus 8 is 44. Okay. So now what we are left with? So this is 3 times. So remember, students, don't forget, if you are cancelling dividend and divisor, then the number by which you are cancelling dividend and divisor, that should be on the left of REM function. If you will not do it, then answer will be definitely wrong. Okay. So REM 7 raised to power 22 divided by 6. Okay. Plus 2 times REM 10 raised to power 22 divided by 9 minus 8. Now I think the question is solved, students. By now we have practiced so much, the answer is visible in front of us. Okay, but still I'm not omitting that one particular step. Okay. So see, this 7 will be replaced by its remainder with 6, and this 10 will be replaced by its remainder with 9. I think most of the students by now would have calculated the answer who have gone through my part 1 and this session. So see, what is this? 3 into REM of, so I will replace 7 with 1, remainder with 6 of 7 is 1. So 1 raised to power 22, it is 1 divided by 6 plus 2 times REM. Remainder, I will replace 10 by its remainder with 9. So which is 1. Remainder of 10 with 9 is 1. I will replace it with 1. 1. And 1 raised to power 22, it's 1 only. So 1 divided by 9 minus 8. Okay. So first part is simply 3. 3 into 1, remainder of 1 with 6 is 1, to 3. 3 into 1 plus 2 into 1, remainder of 1 with 9 is 1, 2 into 1, minus 8. Minus 8. So what are we getting? So this value which you are getting, so this is simply 3 plus 2 minus 8. So value which you are getting is 5 minus 8 minus 3. So we have to make it, the remainder is asked with 18. So value should be between 0 and 18. Value should be between 0 and 18. So I have to add 18 over here. I have to add 18 over here. So this becomes, so this was, what was this value? This was, value was 5 minus 8 minus 3. So minus 3 cannot be the answer. The answer has to be between 0 and 18. So I added 18. I added 18. Minus 3 plus 18 will give us the right answer, which is 15. So answer is 15. Let us see. So answer is 15, students. Very nice. So we solved it using Rem function. It was very simple. I think only the first step was critical, wherein you had to factor out 3 and 2 and keep the factored number on the left. And after that, it was very simple. It was visible on our face that after the second step, the answer will be 3 plus 2 minus 8, 5 minus 8 minus 3, and then we'll add plus 18, so minus 3 plus 18, 15. So 15 is the answer. Simply using the properties of Rem function, we have solved this. And if we see the official solution, then we have to do all this. So I want to avoid all this. Okay. So that is why I explained it to you, the Rem function. Okay. Because it looks complicated. It looks complicated. Next question. Interesting question. Interesting question. So this is somewhere, this is a question in which we are using the concept of remainder, and it helps us to get the answer very quickly. Okay. Although it is PNC, but remainder concepts help us to get the answer very quickly. So we have this number. So see, this number is, so 11 and 13 are already prime. 10 we have to break in 2 and 5. So this becomes 2 raised to power 10 into 5 raised to power 10 into 11 raised to power 10 into 13 raised to power 13. Okay. So now we have to find the number of such divisors which are of 4n plus 1 form. So let me write any divisor of this number. So any divisor of this number, it will be of what form? So it will be 2 raised to power a. So let me write the prime numbers first. 11, 13. So this is any divisor of this number. Any divisor of this number is this, where A, B, C, D, so A is between 0 and 10. Since power is maximum 10, B is between 0 and 10. A, B, C, D are integers. A is between 0 to 10, B is between 0 to 10, C is between 0 to 10, and D is between 0 to 13. But we have to find out those divisors which are of the form 4n plus 1. So I will apply Rem function over here. Okay. So remainder of this value. So remainder of this value with 4. We want remainder of this value with 4 to be 1. Why? Because 4n plus 1 form simply means remainder with 4 is 1. Okay. 4n plus 1, remainder is with 4 is 1. I need not explain it. So 4n plus 1 is, such numbers are 5 and 9 and 13, each of them giving remainder of 1 with 4. So now we have to see the condition on these A, B, C, D so that this remainder is coming out to be 1. Now see, students, if the divisor is of the form 4n plus 1, this number, this divisor is of the form 4n plus 1, then certainly I know this divisor is an odd value. 4n plus 1 is an odd number. So if this is odd, then I can definitely say that A will be equal to 0, because there cannot be any power of 2 in this divisor. This is our divisor. This is our divisor. I'm just writing for more clarity. And since the divisor is 4n plus 1 form, which is odd, so 2 raised to power a, here a should be equal to 0, because for an odd number, we cannot have any power of 2. So a is definitely equal to 0, just one possibility. Okay, students, this much is clear. Next, we will observe 5, we will observe 13, and we will observe 11. So just think of it like we are taking out the remainder of this divisor with 4. Okay, so we will replace 5, 11, 13 with their respective remainders with 4. So this value will become REM. So here we already know it is 2 to the power 0. This is already 0. And 5 I will replace it with its remainder with 4, which is 1. So I have replaced 5 with 1. So 1 raised to power b. Okay. Into 11 remainder with 4 is, though it is 3, but I will use the negative remainder. So 11 is minus 1 away from 12, which is a multiple of 4. So negative remainder is minus 1 to the power c. Very interesting question, students, if you do by this method. And then 13 remainder with 4 is, of course, 1. So 1 to the power d divided by 4. This is equal to 1. Okay, so now things are clear to us. So by now we have understood that A is definitely equal to 0. Okay. And this value over here, so let me multiply. So if you carefully observe, first part is already equal to 1. 2 raised to power 0, this is 1. Okay, so this is 1 only. I will just replace it by 1 only. Then we have, so A value only bicycle value of A, which is 0. 1 raised to power B is always 1, and 1 raised to power D is always 1. Okay, so in order to make this expression, in order to make this numerator, this thing equal to 1, I just need C to be even. B and D can be any real numbers, but C should be even. If C will be even, then minus, so this has to be even. I'm writing it. This thing is even. C is even. Okay. C has to be even. Only if C is even, then we'll have minus 1 raised to power something even, which will give us 1. So numerator will become 1, and finally the remainder we will get will be equal to 1. Okay. So this has to be even. B and D, they can take any values. B and D can take any values. It will not make a difference because 1 raised to power B and 1 raised to power D is always equal to 1. If C was odd, then minus 1 raised to power odd will become minus 1. So remainder of this value would have become minus 1. Remainder of this value becomes minus 1. So minus 1 is a negative remainder. So with 4, we see that minus 1 remainder is equal to remainder of 3 with 4. So minus 1 is equivalent to 3 in case when we are talking with remainder with 4. So if C was odd, then the number would have been of the form 4n plus 3, giving a remainder of 3 with 4. But we don't want that. We don't want 4n plus 3 form. We want 4n plus 1 form. So I have elaborated it to you, although when you will be solving it, so you can solve it in 2 minutes only. So B and D, any real numbers. So B and D, any numbers. Any numbers. And C, by our deduction of remainders, we have found out that C has to be even. C has to be even. Okay, now we have to find the number of such divisors. So see, I will just write down the possibilities, the number of possibilities for A, B, C, D. Okay, so number of such divisors is equal to, so for A, we have just one possibility because A can be only 0. So A only one possibility. What about for B? So for B, we know B can be any number, but B is from 0 to 10. B is from 0 to 10. So we will write here 11 possibilities. I think it is clear for you, everyone, that B will be from 0 to 10. B, C, D are, A, B, C, D were initially any numbers from 0 to 10. No, sorry. This is, I think it is clear to all of you that B will be between 0 to 10 because B is the power of 5. So 11 possibilities for B. Similarly for C, so 11 possibilities for C also, because no. So for C, if we look at C, so C was belonging to 0 to 10. C was belonging to 0 to 10, but we have to just take the even values. So even values will be 6 over here. So this is 6, 0 to 4, 6 and 10. And finally for D, we will have 14 values, because we know D is belonging to what? D is belonging to 0 to 13, and D can be any integer. So no condition on D. B and D are any numbers. So D, we will have 14 values. So 11 into 6 into 14, 66 into 14 is our answer. We can calculate this. What is the value coming? So 660 plus 66 into 14, so 240 plus 24, 264. So this value is 4, 12, 1, 924. So answer is, students, 924. So just by using remainders, we found out the answer as 924. I will repeat it again. It will be very clear to you, and how you will see that this was a 2-minute question, but had to be done carefully. So divisor is of the form 2 raised to power a, 5 raised to power b, 11 raised to power c, 13 raised to power d. We notice that 4n plus 1, since the divisor has to be odd, so 2 to power 0 only is possible. A has to be 0, so that the divisor is odd. So A was 0. Great. A was 0. What about other numbers? So 5 raised to power b, 11 raised to power c, 13 raised to power d. I replace them with their respective remainder with 4. So 1, minus 1 and 1. So 1 raised to power b and 1 raised to power d are anyway equal to 1. So b and d are any numbers. The problem is only with the option will only come with c, minus 1 raised to power c. So in order to make this remainder equal to 1, I had to make c even, because minus 1 raised to power even will give us 1, and then the numerator will be equal to 1, remainder will be 1. So c is even. So after that, it is just simple how you calculate the factors for a particular number. So a value, only one option. For b, we had 11 options, 0 to 10 any number. For c, the number had to be between 0 to 10, but we had to take only even values, so 6 values. And for d, any number between 0 and 13, so 14 values. So 666 into 14, 924 is the answer. So I hope, students, you enjoyed this question. 924 is the correct answer. And here it is. Okay. Here they have written the solution, but they have not given the explanation of why power of 11 should be even. So the explanation is from here. From remainders, we are learning that the power of 11 should be even. The value of c should be even. So 924 is the answer. Great, students. 4 more questions to go. Let us proceed. Very interesting question, this one. Okay. Very simple question, student. Very simple. देखो क्या लिखा है. Probability that a randomly selected 2-digit number n is a 2-digit number such that 2 raised to power n minus 2 is a multiple of 3. So if 2 raised to power n minus 2 is a multiple of 3, so it is, say, of the form 3k. So this simply means 2 raised to power n, this is equal to 3k plus 2. 2 raised to power n is 3k plus 2. So basically remainder of 2 to the power n with 3, remainder of 2 to power n with 3 is equal to 2. Because it is of the form 3k plus 2, so this is equal to 2. So let us use our remainder properties. So I will say REM replace 2 with minus 1. So replace 2 with minus 1, because remainder with 3 is 2, but we will write the negative remainder minus 1. Raised to power n by 3, this should be equal to 2. So from here we observe that if n is odd, then this remainder will come as minus 1 raised to power odd, and minus 1 raised to power odd is minus 1. So minus 1 will become minus 1 plus 3, 2. So for this to hold, n has to be odd. So for this to hold, this implies n is odd. If n was even, just for an explanation, if n was even, then the numerator will become this minus 1 raised to power n, minus 1 raised to power even, which is 1. So then the remainder value over here will come out to be 1. Remainder will become 1, which is something that we don't want. So clearly n has to be odd. Now see, how many 2-digit numbers are there? So from 10 to 99, there are 92 digit numbers. Okay, basic PNC, 92 digit numbers are there. And how many of them are odd? 45 of them are odd. Half of them are odd, half of them are even. So what is the probability? 45 by 90 is the probability. So answer is 1 by 2. So 1 by 2 is the answer. From 10 to 99, there are 45 even numbers, 45 odd numbers. So probability is half. So half is the answer. Very simple, basically nothing in this question. You just had to do this step and identify that n has to be odd, and that is it. So see, now our concepts are becoming so clear. So n was odd, so this is half. Here they have written n is odd, but the explanation is through remainders. Okay, students, let us proceed. We are done with 3 questions, 3 beautiful questions ahead. So half. Okay. This one is a standard question. So we have done so many such questions. We are in a position to correctly attempt this question. Let us go. So remainder of 2021, standard question 3762 with 17. Okay, this came in JEE Main PYQ. So first step is, students, remainder of 2021 with 17. 2021 with 17. So how much is it? 17, 32. 32, it will give 151, 170, 153. Okay. So either you can say the remainder is 15. Okay. Because either you can say the remainder is 15. You do this calculation, it will come out to be 15. Last thing, it is coming 151, 153, 170. Okay, so either you say remainder is 15 or you use a negative remainder that this value is minus 2. So when you will divide 2021 and 17, you will get the remainder as 15. But instead of 15, I'm using the negative remainder minus 2 because it is a much smaller value. It will help us solve the question. Okay, so let us proceed now. So we will replace 2021 with its remainder with 17. This becomes remainder of minus 2 raised to power 3762 with 17. Great. Now good thing is 3762 is even. So this will become remainder of, so minus 1 raised to power even is 1. So this becomes remainder of 2 raised to power 3762 with 12, with 17. Okay, now students, closest power of 2 which is closest to 17 or a multiple of 17. So it is visible to us. 2 raised to power 4 is 16. So 16 is minus 1 away from 17. Okay, so what I have to do, so just for your understanding, I'm writing it over here. We will use the fact that remainder of 2 raised to power 4 with 17, 2 raised to power 4 with 17, this is equal to minus 1. So we will use this fact. Okay, so we just have to break 3762. We have to break 3762 into parts of 4. So let us do this activity. 3762. This is equal to 4 into how much? So this is 9, then 1, 6. This is 4. Okay, and then 0 plus 2. So this is 4 into 940 plus 2. I have just broken 3762 into parts of 4. Now this value will become equal to remainder of. So this is 2 raised to power 4 raised to power 940 into 2 square divided by 17. Great. Let us proceed. So this value becomes, let me write it here in the last line. So from here we are going to here. Okay, this is equal to remainder of, so this 2 raised to power 4, this is 16. 16 remainder with 17 is minus 1. 16 remainder with 17 is minus 1. Minus 1 raised to power 940, minus 1 raised to power something even. So that will become 1 only. So all in all, this value will become 1 and we will be left with remainder of 4 with 17. I could have written it over here also. So this thing becomes equal to remainder of, so first thing is 1, 4 with 17. So remainder of 4 with 17 is, we know this is equal to 4. So answer is 4. So let me separate them. So answer is 4, students. So see how expert we have become in remainders. You got the answer of 4 in, so when you will solve it, I had to explain it to you. When you will solve it, within a minute you got the answer as 4. Let me repeat it once again. So 2021 remainder with 17, instead of 15 I took it as minus 2. and then I replace 2021 with minus 2 raised to power 3762. This becomes 2 raised to power 3762 because minus 1 raised to power even is even. Then 2 raised to power 3762, I learned that a power of 2 closest to 17 is 16. So remainder of 16 with 17 is minus 1. Using this fact, I broke 3762 into parts of 4. So this becomes 4 into 940 plus 2. So this is 2 raised to power 4 into 940 into 2 square. So 2 raised to power 4, this is 16 raised to power 940. Remainder of 16 with 17 is minus 1. So minus 1 raised to power 940 minus 1 raised to power even. This value became equal to 1. This value became equal to 1. And 1 into 2 square, 1 into 2 square, 1 into 4, remainder with 17. This is answer is 4. So fairly simple question, students. Fairly simple question if you know how to use remainders. Okay, great. So let us move forward. Answer was 4. I think the objective of this session is now solved. You are able to do the questions. A couple of questions more. Last question is wonderful. Let us proceed with the next one. So here answer was 4. And whatever method they used, better to use, but we have learned. Oh, this is another question. Total number of 2-digit numbers. Okay, so total number of 2-digit numbers, we know they are 90. From 10 to 99, 99 numbers are there. Such that this thing, 3 raised to power n plus 7 raised to power n is a multiple of 10. Okay, so they are simply saying multiple of 10 means that 3 raised to power n, this number gives a remainder of 0 with 10. Okay, gives a remainder of 0 with 10. So basically, we just have to focus again on the unit digit of this number. So whenever divisibility with 10 is given, we just have to check. I will just write it again. Whenever divisibility with 10 is given, we just have to check the unit digit. We just have to check the unit digit. And we are done. So for unit digit, we know for both 3 and 7, the cyclicity is 4. So best is that we calculate the value of the unit digit for this number for n equals 1, 2, 3, 4, and then that cycle will repeat. So see how we will do this. We know that for calculating unit digit of 3 and 7, there is a cyclicity of 4. So just see for n equals 1, 2, 3, 4, and then this cycle will repeat. So first I will put n equals 1. N equals 2, n equals 3, and n equals 4. Okay, so what we are getting? We are getting 3 raised to power 1 plus 7. Two conclusions. Either say for, or you can say for half of the numbers. For half of the numbers, because out of 4 cases, for 2 cases we are getting this. So for half of the numbers, so better you say this. Better you say this. So for n equals odd, we are getting 3 raised to power n plus 7 raised to power n is a multiple of 10. So for how many 2-digit numbers are odd? So I told you 2-digit numbers, they are 90, out of which 45 are odd. So 45 is the answer. 45 is the answer. Very simple question, student. Very simple. कुछ नहीं था इसमें. See, 3 raised to power n plus 7 raised to power n should be a multiple of 10. Okay. So first I found that since multiple of 10, I'm concerned with unit digit. Unit digit should be 0. That is my aim. Unit digits should be 0. Of 3 raised to power n plus 7 raised to power n. Then I knew that cyclicity of the unit digit for 3 and 7 is 4. So I just have to check for n equals 1, 2, 3, 4, and then cycle will repeat. So I checked for n equals 1, 2, 3, and 4, whatever the unit digit coming out, and I got to know that for n equals 1 and n equals 3 only, the unit digit is 0. So basically, out of n equal to 1, 2, 3, 4, only n equal to 1 and n equal to 3 were giving unit digit 0. Basically, for n value, odd values of n, this number is becoming multiple of 10. So odd values of n, how many are there? There are 45 odd values of n. So there are 92-digit numbers, out of which 45 odd numbers are there. So number of 2-digit numbers which are odd is 45. Answer is 45. Very simple question, students. So answer is 45. So here they have written it directly. So n can be any odd number, but the reasoning behind this is this. The reasoning behind this is this. Okay, students. So let us do the last question, my favorite question. Okay, lot of learning here. Last question, my favorite question. So see, remainder when x is divided by 4 is 3. Remainder when x is divided by 4 is 3. So remainder when x is divided by 4 is 3. This implies I'm in no mood to use binomial. I will just use my remainders concept. So here I can say x is something which is of the form 4k plus 3. Okay, x is something of the form 4k plus 3. Okay, what we are asked remainder of this value 2020 plus x raised to power 2022 divided by 8. Interesting question. Okay, now see, I will do the usual steps. So I will do the usual steps. So first step will be what? Replacing this 2022, replacing this 2022 with its remainder with 8. So I will write it like this. This is equal to remainder of, replace 2022 with its remainder with 8. So what is its remainder with 8? So for 8, basically we see just the last 3 digits. Remember the rule I told you yesterday? For 2 raised to power n, we see the last n digits. So for 2 cube, which is 8, we'll see the last 3 digits. So we see just 0, 0 to 0, 20, and the remainder is coming out to be 4. So this is 4 plus x raised to power. So I will just keep it like this. 4 plus something plus 2022 divided by 8. Okay, now here I also want to put the remainder. So I want to replace x with its remainder with 8. Okay, so what I want to know is what is the remainder of x with 8? This is what I want to know. Now for that a condition is given to me. The condition is x equals 4k plus 3. So it's telling me that with 4 the remainder is 3, but with 8 I don't know what is the remainder. Okay, so that is the problem. With 8 I don't know. 1 second, students. So now what to do? I don't know what remainder will be coming from 8. I know x gives a remainder of, with 4 the remainder is 3. For x with 8, what will be the remainder? So don't worry, just do it like this. So see what series this is coming. So just write down the numbers which are of the form 4k plus 3. So x can be equal to either 3, put k equals 0, put k equals 1, 7, or 11, or 15, or 19, and so on. Okay, now keep on checking the remainder with 8. So here the remainder with 8 is 3. Here the remainder with 8 is 7. Here the remainder with 8 for 11, remainder is 3. For 15 the remainder with 8 is what? 7. And for 19 the remainder with 8, is 3. So basically we are alternating with 3 and 7. So remainder of x with 8, it is either 3 or 7. Okay, when it will be 3, when it will be 7, this is also very clear, although we need not know it, but just for more clarity. So see, x equals 4k plus 3. So I'm keeping two cases here. First case is that k is some even number. So say k is of the form 2m, and second case k is of the form 2m plus 1. So k can be either even or odd. Any number can be either even or odd. So either it is 2m form or 2m plus 1 form. Okay, 1 second, students. So if k is 2m form, then how can I write x? Then what will x become? Then x will become equal to, just replace k with 2m, x becomes equal to 8m plus 3. Okay, and if k is 2m plus 1, then x becomes equal to 8m plus 4 plus 3. So 8m plus 7. So if k is even, the number is of the form 8k plus 3. That means the remainder with 8 is coming out to be 3. And if k is odd, that is of the form 2m plus 1, then x is equal to 8m plus 7. That means remainder with 8 is coming out to be 7. So these are the two cases. If k is even, k is odd, depending on k even odd, x can give either 3 or 7 remainder with 8. So if this much is clear, now we can proceed with the question, and it becomes an interesting question. So see, so next step logical was that I replaced 2022 with its remainder with 4. But I now have to replace with its remainder with 8, because divisor is 8. But now I have to replace x. Here divisor is 8, clearly, as per the question. Now I have to replace x with its remainder with 8. So there are two cases. Either at this value I can put 3, or here I can put 7. Two cases will be there. So I have to make both the cases. So let me make the other case. Remainder of 4 plus raised to power 2022 divided by 8. Okay. So what I learned, that remainder, I'm just replacing x with its remainder with 8. So either the value is 3 or the value is 7. Okay, now let us calculate these individual values. So this value is coming out to be remainder of 7 raised to power 2022 with 8. And this is coming out to be remainder of 11 raised to power 2022 with 8. Two possibilities. Now how we will solve these standard? So next step is I will replace 7. I will replace 7 with minus 1. I will replace 7 with minus 1. So this will become remainder of minus 1 raised to power 2022. Minus 1 raised to power even is 1 only. So minus 1 raised to power even 1 divided by it. So this is equal to 1. Great. So answer is equal to 1 if we are considering the remainder of x with 8 as 3. So answer is coming to be 1 in this case. What about this case? Ideally, if this is a subjective question, integer type, there is only one unique answer. So answer should be 1 for this case also. But is it happening? We have to check. So this is remainder of, now replace 11 with its remainder with 8. So I will put it like this: 3 raised to power 2022 with 8. Okay, what next? Now I know closest power of 3 to 8. Closest power of 3 to 8 with 8 is 3 square 9, which gives the remainder of plus 1 with 8. So I will just write it as break 2022 in parts of 2. So basically it can be done easily. It is 2 into 1011. So this becomes remainder of, so 3 square. Let me write it on the left side, students, so that it is clear. Here this answer was 1. Here this answer was 1. And we have to check since what is the answer in other case. Okay. So this thing becomes remainder of d raised to power 2022. So this is 9 raised to power 2011. 9 raised to power 2011 with 8. Okay. And now I will replace 9 with its remainder with 8. I know most of the students have got the answer by now, but still I'm explaining the steps. So remainder 9, remainder with 8, replace 9 by its remainder with 8. So this simply becomes remainder of 1. Replace 9 with 1, which is its remainder with 8, raised to power 2011. So 1 raised to power anything is 1 only. So this is remainder of 1 by 8. We replaced 9 by 1 because it's its remainder with 8. So remainder of 1 by 8. 1 raised to power anything is 1. So what is this value coming out to be? This value is also coming out to be 1. So in both the cases, the value is 1. Whether we take remainder with 8 of x as 3, or whether we take remainder of x with 8 as 7, the answer is 1 in both cases. Answer is 1 in both cases. Okay. Answer is 1 in both cases. So answer for this question is 1. 1 is the answer, friends. So very nice, friends. This is how it's question. I love this question. See again. So इसमें क्या किया हमने? First I checked the condition for x. So condition for x was the x is equal to 4k plus 3 form. X equals 4k plus 3 form. So I deduced basically with 8 it is giving either a remainder of 3 or a remainder of 7. So when calculating, when using the Rem function, by taking this big number was there, and I had to take its remainder with 8. So I had to replace 2022 with its remainder with 8. I did it. It was 4. But similarly, I had to replace x with its remainder with 8. So there were two cases for this. Either I could have put 3 over here, or I could have put 7 over here. So when I used 3 and did the calculation, answer came out to be 1. And coincidentally, when I used 7 and did the calculation, answer came out to be 1. So irrespective of the fact that x gives a remainder of 3 or 7 with 8, if x is of the form 4 plus c, then this particular expression, this particular number in terms of x will always give a remainder of 1, when divided by 8. So the question was designed in such manner. So answer was 1. This is the solution by binomial. You can refer to this also. And I have also given you the solution by my method. So students, that is it for now. We have completed this chapter on remainders. Okay, answer was 1. So coming back to the contents. So we did textbook question 6 and JEE Mains 2021 PYQ 6. So I think this amount of practice is enough for remainders. Okay, if you have not seen the part 1, go and watch the part 1. And lastly, just practice these total 22 questions all by yourself. So once you will practice all these 22 questions all by yourself, then you will become as proficient as I am, as much expert as I am in handling such questions. So thank you, students. Hope you liked it. If you like the session, just like